In this lesson, Module 3, Lesson 2, we're going to talk about more rational numbers. Last class, we talked about integers, and integers are positive and negative whole numbers. So we looked at -2, for example, on a number line. -5 would be an integer, +10. Any of those positive and negative whole numbers that we worked with last class would be part of the rational number family. Rational numbers also include fractions. Okay, so like 1/2, 3/5. These are all rational numbers. Terminating decimals. Terminating means that they stop at some point, right? 0.6, 0.3214. As long as it comes to an end and they stop, those are called terminating decimals. That is also a rational number. And the last one are repeating decimals. So decimals that go on and on and on, but they have a pattern to them. So for example, 0.3333, and it would continue going on. You could have another pattern like 646464. That would also be a repeating decimal. These are all types of rational numbers that would be included here. Things that are not included would be a decimal that that does not repeat, like pi, which would be 3.141592, and it keeps going, but it never repeats. That would not be a rational number. So from here, we're going to talk about where rational numbers are on our number line. Rational numbers on a number line can be in between whole numbers. So if I go from 0 to 1, I also have numbers in between them. They're just not whole numbers, but they would include our rational numbers like fractions and decimals. So if I want to locate and graph the number 3/10 and its opposite on a number line, let's start with 3/10. 3/10 indicates that there are 10 sections in the whole number. So between 0 and 1, I would have to divide it up into 10 sections. And as we did our tape diagrams, we know that we need to make 9 lines to make 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I wanted to double check to make sure that there's 10 jumps to get to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have broken up my whole number into tenths. And I'm going to do the same thing on my negative side. 1, 2, 3, 4, 5, 6, 9. And we're going to try our best to make them as equal parts as possible. Not always going to come out perfect. So now that I have broken them up into tenths, I'm going to now graph 3/10. I always start counting from 0. And we talked last class, to the right is my positive. So this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then 1 would be equal to 10/10. So I've numbered it correctly. I'm just going to put a dot at my line where my 3/10 is, and that's how I'm going to graph that. Okay, going the other direction to the left are my negatives. So I have -1/10, -2/10, -3/10, and so on. But I'm just going to stop there for today, and I'm going to graph my number -3/10, because it told me in the problem to graph 3/10 and its opposite. Yesterday we learned that we just changed the sign for opposites. So the opposite of 3/10 would be -3/10.